Okay, I'm going to go through surface area of the other figures more quickly than the prisms, I promise. For cylinders, we're looking at this formula for surface area, but you should notice some things. We haven't gotten to the circle unit yet. That's going to be our last unit, but you might recognize from grade school that this pi r squared part is the area of a circle. So this is actually that 2 times the area of the base part. And then that 2 pi r is circumference of a circle. So this part you can kind of think of as that perimeter times height. So remember how we talked about the cylinder being kind of like a circular prism? Well, our formula really looks like the formula for a prism. Okay, so something that's important when we're picking out things, really we've just got the radius and the height to plug in. Make sure that your radius is that distance from the center of the base to the side. So here in a minute on number 2, they actually gave you the diameter, so you're gonna have to find the radius first. Something else that's gonna come into play is that we do have pi in our formula. So we're gonna have 2 different ways that we can write the answer. Okay, so I'm going to go ahead and simplify either side of the plus sign. So we've got 121 times 2, so a 242 pi. And then I can't do that one in my head. Let's do 22 times 26. So 572 pi. Okay, so one of the ways that we can write our answer is by leaving it in terms of pi. And a lot of times the directions will say leave in terms of pi. So if we want to leave it in terms of pi, I would go ahead and add these and treat pi kind of like a variable. So I would be adding my 242 plus 572, just like this was like a 242x plus 572x. And I'm going to get 114 pi yards squared. So this is one way that I could write my answer, and again, this is called in terms of pi. Another way that you could write your answer is by actually multiplying by pi. So you can use the decimal approximation for pi, 3.14, or you can use the actual pi button. I honestly lean towards the pi button. It is the most accurate because it's giving you more decimals of pi than you can have memorized yourself. On this calculator, it's just second, and then this button right here has the pi. And we're going to get about 2,557.3, and it was yards. So where you might want that in terms of pi is that this 814 pi is an exact answer, just like when we have radicals in our answer, it is exact. Whereas when we put it in the calculator, we not only had to choose between using 3.14 and pi, but then we also had to round. So this isn't exact, we had to round to that 0.3. But for what we're doing, I would follow whatever instructions your teacher is giving you or whatever instructions the problem gives. Either of these are valid answers for the surface area. Go ahead and try number 2 on your own. So you should be getting 247.5 pi in terms of pi, and then 777.5 meters squared rounded to the nearest tenth. If you're not getting either of those values, you might make sure that your radius you're plugging in is 7.5. Make sure that with that area part that you squared it, and then your height should be a 9. If none of those things are incorrect, then you might try plugging that into your calculator again. Which brings us to pyramids. In pyramids, we're going to have a new dimension here because it has a true height that is perpendicular to the base, but then it also has something that we call a slant height. And we use this cursive L to denote slant height. So our formula is going to be this 1/2 slant height times the perimeter of the base plus that area of the base, that capital B. So make sure that you've got the slant height, and if you don't have it, we'll have to find it. So for example 1, they did give us the slant height. Notice it's that height of the side and not the height of the figure itself. So 11.7. The perimeter of the base, since our base is a square, we've got 8 plus 8 plus 8 plus 8, or we can take 8 times 4. So our perimeter there is going to be 32. And then the area of the base, again, since it's a square, I'm going to have 8 times 8 for the area of my base. So we should get 251.2 meters squared. Go ahead and try number 2 on your own. So for number 2, again, they gave us the slant height, so we're good to go there. So our slant height is at 7.4. Finding the perimeter, we've got 5 plus 5 plus 5 plus 5, so 5 times 4. And then for the area of our base, again, we have a square, so 5 times 5 would be the area of our base. For number 3, we're not going to do another full example of this, but I do want you to see an example where you don't have the slant height. So if you don't have the slant height, it is part of our surface area formula, so we need it. We're going to go ahead and draw in a right triangle where that length, the right angle to the top of the pyramid, is the height of the figure. So if I redraw it out here, I've got this leg is going to be 3. That was the height of the figure. The length from the middle of the base to the outside of the base is going to be half of that length of the base. So since the length is 16, half of that is going to be 8. And now I can just use Pythagorean theorem to find my slant height. And get that the slant height is about 8.544. I want to go several decimal places here. I try to go at least 3 decimal places within the problem, and then at the end I can use whatever rounding rules they ask for. And we're not going to do this whole problem because I think we're getting the hang of it, but that would be my slant height, and now I could go back and use my formula and use that slant height for the L. Okay, so we've got cones and spheres left, and I'm just going to do one example of each of these because I'm getting kind of tired, so I know you guys have to be tired of listening to my voice. So with the cones, we've got this formula pi r squared, which is that area of the base, plus pi r times the slant height. So we have a slant height in this one as well. Still that cursive L. So in my first example, I'm given the radius. I'm also given the slant height, so I don't have any issue here. Got my 7 for all of the radii, 11.4 for the slant height. Because the cone has a circle in it, I'm going to end up with those pi's, and again, I can either leave it in terms of pi or round it to the nearest tenth. And we should get either 128.8 pi meters squared or about 404.6 meters squared. So some things to remember on the other ones. We're not going to go through any more examples for the cone, but make sure that you're choosing the radius. So on the second example, I would have to cut the diameter in half to use my radius. And then just like the examples we were looking at for the pyramid, if I'm not given the slant height, or actually in this case, I'm not given the radius, but I can still turn that height, half of the base, and the slant height into a right triangle. And just like I did on the pyramid example, I can use Pythagorean theorem to find the radius. So our last solid that we're going to look at is the sphere. We've got that the surface area for the sphere is 4 times pi r squared, which does make it seem like there are 4 circles involved here. This is actually pretty neat. If you have an orange at home, or a cutie, a halo, something like that, and you draw 4 circles that are the same circumference as your orange, and then you peel that orange, you should be able to fill in the 4 circles with your peels, because the surface area of your orange is 4 circles that have that same radius. So kind of interesting. Let me know if you try it. So we really just need to identify what the radius is. For this one, the radius is going to be half of that diameter, so we've got 4 pi times 12 squared. And again, we can leave it in terms of pi, or we could not. In terms of pi, you should get 576 pi millimeters squared, and then rounded to the nearest tenth, it's 1,809.6 millimeters squared. Okay, so you can't just focus on the one toy, because really your main focus is that you want to be where the people are. So you don't have actual legs. You've got a tail, and you want legs. You want to be where the people are. You're just fixed on this one toy.